A clock ticks. Each sound is a reminder that the world is moving forward, that hearts are beating, that seasons are turning, that galaxies are still unfurling their arms in the dark. But imagine, for a moment, that the ticking ceases, not because the mechanism has broken, not because the universe has grown quiet, but because the very flow of time itself has stopped. Time. It is the invisible current that carries existence. It moves every atom from one moment to the next. It cradles memory. It opens the door to the future. Civilizations rise upon its steady march. Stars live and die within its embrace. Life itself is written only because time allows one second to follow another. We think of time as eternal, a river that will always flow. But rivers dry, currents falter. And in the language of physics, in the equations of Einstein, in the whispers of quantum theory, a darker possibility emerges. Time is not an unbreakable law. It is fragile. It is contingent. And long before equations, before telescopes, before even the first civilizations, human beings lived by rhythms. The rising and setting of the sun carved the boundaries of the day. The moon, in its patient waxing and waning, etched a calendar across the sky. The seasons carried the promise of planting, the warning of winter, the return of spring. For early humans, time was not an abstraction. It was a cycle, a wheel, repeating endlessly. A circle that defined survival. To them, the universe was eternal and unchanging. The heavens moved above them in patterns that seemed absolute, beyond the reach of decay. But in this quiet observation, something deeper began to stir. A realization that time was not simply the background to life. It was the very force by which existence unfolded. Centuries passed, mathematics grew, astronomy matured, and with it came Isaac Newton, who sought to bind the universe to laws as precise as clockwork gears. In Newton's cosmos, time was absolute. Time has always seemed like a certainty. It flows unbroken from past to present, from present to future. Its arrow points forward with a steadiness that feels as immutable as the stars themselves. But in the quiet language of physics, discoveries have whispered a darker truth. Time is not guaranteed to flow forever. The shock first emerged not from the heavens, but from the furnace of physics itself. In the 19th century, scientists began to probe the nature of heat, energy, and disorder. From their work arose the laws of thermodynamics, rules that bound every engine, every star, every living system. And hidden within those rules was something profound. The reason time seems to move forward at all. In a universe governed by the second law of thermodynamics, entropy, disorder, always increases. A glass shatters, but never reassembles. Heat flows from hot to cold, never the reverse. Smoke disperses into the air, never gathers back into flame. This simple principle, define. The universe carries within it a record of its own birth. A faint whisper, stretched thin across the cosmos, arrives from every direction. It is the cosmic microwave background, the afterglow of the Big Bang, still glowing more than 13 billion years later. Frozen in this ancient light is a portrait of the infant universe. Tiny ripples of temperature, mere fractions of a degree, reveal the seeds of galaxies and clusters yet to form. But hidden within this pale radiation is something more. Evidence that time itself had a beginning. The microwave background shows a cosmos once dense, hot, and unimaginably young. Its uniform glow tells us that space and time themselves expanded from that singular moment. The arrow of time, tied to the cooling and dispersal of this fireball, was born here, not eternal, not infinite, but emerging with creation. From this, scientists learned something unsettling. Time is not outside the universe. It is woven into it. bound to its birth. There are places in the universe where time bends until it nearly halts. But there are also frontiers where it does more than bend. It fractures. It ceases to exist in any form the human mind can grasp. At the heart of a black hole lies one such frontier. Beyond the event horizon, all paths lead inward. Gravity grows without limit, crushing space and slowing time until it stretches toward infinity. For an outside observer, an object falling into a black hole appears frozen. Its final image hangs at the edge of the horizon, red-shifted and fading, as though eternity itself has captured it. But for the object itself, time continues, swiftly, unrelentingly, until it reaches the singularity. And here, the mathematics breaks. General relativity predicts a point where density becomes infinite, where the curvature of spacetime is no longer defined. At that boundary, time cannot extend. The equations that describe the universe everywhere else fall silent. In the singularity, time has always been imagined as an infinite river flowing without beginning and without end. But physics suggests otherwise. Its currents may thin, its channels may fracture, its waters may evaporate entirely. The universe, it seems, carries within it the seeds of time's demise. And from those seeds emerge visions of endings, each stranger, each more unsettling than the last. The heat death. The first vision comes from the relentless climb of entropy. Every star that burns, every atom that collides, every thought that flickers in a living mind increases the disorder of the universe. It is the second law of thermodynamics, unyielding, unstoppable. As billions of years pass, galaxies dim, stars exhaust their fuel, matter collapses into black holes, which themselves evaporate over inconceivable spans of time. Energy is spread thinner and thinner until no structure remains. This is the heat death, a cosmos at maximum entropy, where nothing new can form, no events. The human species has always searched the sky for answers. Once, those answers came from the naked eye. The rising of constellations, the wandering of planets, the rhythm of eclipses. But today, humanity commands tools that stretch vision across cosmic gulfs, instruments so sensitive they can trace the faintest tremor in the fabric of reality itself. Through them, the universe is no longer a silent mystery. It becomes an open book, one in which time itself may be beginning to reveal its fragility. The James Webb Space Telescope, suspended 1,000,000 miles from Earth, orbits in cold silence. Its golden mirrors unfold like the petals of a cosmic flower, tuned to the faint glow of infrared light. Through Webb, astronomers can glimpse galaxies born when the universe was less than 1 billion years old. Snapshots of existence drawn close to the very moment time began. In each image, spirals of stars shine across the void, their light stretched by cosmic expansion. These pictures, the question lingers like a shadow at the edge of thought. What would it mean if time itself were to end? Not a pause, not an intermission, not even an eternal silence, but the absence of then. For every creature that has ever drawn breath, existence has been a sequence. Moments following one another, each giving birth to the next. It is in this unfolding that life finds its rhythm. The beating of a heart, the rise and fall of a tide, the flicker of a star against the night. But if the river of time were to stop, the sequence would break. No future, no becoming, not even nothingness. For nothingness itself requires duration to be sensed. It would simply be the end. Every civilization, every memory, every dream humanity has ever known is built upon this fragile current. The pyramids rising against the desert, the voyages across unknown seas, the spark of electricity harnessed into light. All of it is scaffolding raised upon borrowed seconds. A cathedral of Mia.